Jack Ma, and I have been working here for 14 years. So here are today's objectives. First, we want to review the syllabus, right? I give you one copy for each of you guys, and we have a syllabus, and we talk about this syllabus in detail, so we know what we are going to learn, and what is my expectation from you, and what how I'm going to assess you guys' performance, and finally how we give the final grades. Also, we'll talk about some important policies. And after that, we will talk about the introduction to fractal mechanics. So the syllabus, this is a technical elective, and also the graduate course. We have who are graduate course students? Please raise your hand. Sergey, right? Sergey, maximum. All other students are undergraduate students. Okay. And so lecture, we have lecture MDH 2080. This room are from 12 to 12:50 p.m. Monday, Wednesday, Friday. So here is office hour. Please let me know if this office hour works for you. Please raise your hands if this office hour, I'm sorry, this is AM. If this office hour does not work for you, please raise your hands. Bobby.
Oh no, it's not really.
Okay, does not work for you, right?
Yeah.
Okay, so can you come to my office if you have any questions? We have Zoom meeting, or we can make a personal appointment.
Yeah.
Okay, so the reason I want this one is that last semester I selected time slot from 11 to 12 because that is close to the lunch time for me and for my students. Also, only 2 students for the whole semester stop back, and that's the reason I want to have this time slot for our office hour. As I said, if this one does not work for you, we can make a personal appointment and to talk. Okay, so this is just our official office hour, and virtually, and it will be held virtually and also in person. My office door will be open, and at the same time, I'm going to start my Zoom meeting. If you have, you can join the office hour via Zoom. Questions regarding the office hour? And then regarding the textbook, so this is the fractal mechanics. This is Anderson. Dr. Anderson is the very bigger guy in fractal mechanics. So fundamentals and applications, and you can either use the 3rd edition or the 4th edition. Now currently, the 5th edition is available, and the publisher they just sent me email and to review Dr. Anderson's the 5th edition. But currently in the market, the 4th edition is the latest one. So it is better to have this one, right? And the Abacus modeling handouts, I will give you, and we will use Abacus to do the modeling of the fractal mechanics. So we're going to use the Abacus. And Abacus online documentation, you can use it through Blackboard Learn. I'm sorry, so this is not true anymore. This should be through Canvas, okay? Through Canvas. And we will use the through Canvas as a platform for our almost all communications. And topic prerequisite, if you have taken mechanics of solids and or the computer-aided engineering, that will be very good for you to understand the concepts or the principles, equations to be covered in the fractal mechanics. So unluckily, the computer-aided engineering is removed from our curriculum. Questions regarding this slide? No question? Look at the next one. The course information. So this course provides introduction to the fractal mechanics concepts and applications. The topics include the asymptotic solution for stress at a crack tip, energy balance and crack propagation, and computing stress intensity factors, fatigue, crack growth, fracture of concrete, computational fracture mechanics, applications, and current topics. And so maybe you, I think some students, if you have taken the courses with me, I mentioned the stress intensity factor, right? Right? And stress intensity factor, and so this concept is exclusively for the fracture mechanics. And we have a very, very similar the factor called the stress. What do we call this stress intensity factor? Stress concentration factor. You guys know concentration factor, right? Stress concentration factor. If we have some defects in the specimen, at the edge of the defects, and we usually have stress concentration because of defects. As a stress concentration factor. Now the stress intensity factor is exclusively for fracture mechanics, for cracks. So this is whenever you talk about the stress intensity factor, people immediately know, and you are talking about some cracks. So this is the basic course information. And then the course objectives, after you guys take this course, so you are supposed to know all these concepts. First one, you should be able to explain the concept of fracture toughness. What is the toughness? Maybe you already know what is the toughness, especially if you have taken CAE with me or machine design with me. The toughness, you have some ideas, right? And toughness means it is indicator for this material to fracture. It's the toughness. And so you should be able to calculate, either use your hand using equations, or use FEM, abacus, calculate the stress intensity factor. And also J is integral, and the COD is a crack, COD for cracked body. So this crack, the distance, the crack distance, crack tip distance. I'm sorry, CTOD. I'm sorry, guys. CTOD, crack tip distance. J is integral is especially for this crack tip. So this is new concept. If you know J and the CTOD, and you need to leave. Okay, guys? Don't worry, no worries. These two concepts are totally new in this course. Apply energy approach to fracture problems. Energy approach. And describe and predict fatigue crack the growth behavior. If we have the crack on this specimen, now we apply this repeated cyclic loading. And how can we predict the crack propagation? So we will learn how to do that. Right? And so we will prepare and perform basic fracture tests. And basic fracture tests. And this is, if we want to do some tests, we must follow some procedure. And we call the ASTM procedure. You guys know ASTM procedure, right? ASTM, American Standard, the testing and measuring. ASTM, we'll talk about this one. So whenever we do something, and we are need to follow some ASTM, and then ASTM then give a number. And for example, the tensile test, and there is the ASTM, this protocol standard. I forgot the name, the number. But for this fracture testing, I will have different ASTM. So the obtain information from studying fracture surface. If we have a fracture surface, right, and based on the characteristics of the fracture surface, and you should be able to know and what is the problem to cause this problem, to cause this characteristic, this kind of fracture surface. What happened? Then analyze deformation and fracture problems using research FEM software. We will use abacus. And apply the knowledge of fracture mechanics in design and safety assessment of structures. So this is our course objectives. Questions for this slide? So write down, guys, here is a CTOD, corrective distance. Corrective, you can see this is a correct. This is a corrective CTOD, means that it's a corrective. And for some distance from the corrective, and how far it is for the opening, that is called CTOD. The tentative topics, in order to get all these, accomplish all these objectives, goals, and we are going to talk about this. Okay, so we talk about course overview and history of fractional mechanics. Fractional mechanics is relatively new. It starts in early 20th centuries, just after the First World War, because the necessary, because the applications. We talk about linear elastic fractional mechanics. This is the basic. This is the fundamentals. Right? Just like the elasticity. This is the basic. Then we have plasticity. Linear elastic fractional mechanics, then elastic plastic fractional mechanics. And then fracture mechanics in metals, fracture mechanics in non-metals, and fracture toughness of metals. And then we talk about fatigue crack propagation, and then computational fracture mechanics. So this one means that you use some software, and for us, and we will use FEM to be more specific, and we use Abacus and to do this fracture mechanics analysis. That's called computational fracture mechanics. But because in reality, most of the problems cannot be solved using hands, using equations. You need to use this numerical method to solve these problems computationally. Any questions so far? FEM, to be more specific, FEM, we use FEM. So assessment method, we have homework assessments and hand calculations and or computer assignments. We have these homework assignments, and we have take-home quizzes, and we have take-home midterm. And finally, we will have the take-home final exam, which will be held on December 9th, Monday, 2024. So how many hours I will give you, and we will talk about this prior to the exam, as we did before, right? And all homework assignments, take-home exams, and quizzes will be sent out to students in PDFs via emails, and will be collected in PDFs via emails as well. I send this one to you, and you finish, and then send me back. Then I grade and send me graded homework assignments back. So evaluation and homework and quizzes on 50%, midterm 20%, and final exam and 30%. I need to tell you guys, okay, homework and quizzes are very, very important. If you miss too much for this one, the final grade will be very, very low. So these quizzes, to be specific, quizzes are modeling assignments. I will give you the video, and you watch the video and follow my video step by step. After you finish, after the video finishes, and you finish your work. So final letter grade, we have standard letter grade, 93% or above, and you guys will get an A. Below 60, and this is F means that this guy needs to retake this course if you want, and this on the transcript. Any questions regarding the syllabus? Michael?
For the quizzes, is that when we're going to be using Abacus?
Abacus, yeah.
Okay. How often do you think we'll be doing that? Like every other week?
We have two.
Oh, okay.
We have two, but very, very big.
Okay.
But very big, okay? We only have two quizzes. One quiz take about 3 weeks, one quiz take about 4 weeks. It's a lot of fun. Yeah, alright? I'll give you the everything, all the detailed steps. Okay. Questions? No question? Okay, important points. Important notes. So we will meet face to face this semester. And so lecture attendance is highly recommended. Let me tell you this way. Okay, so on syllabus, I said lecture attendance is highly recommended. I need to tell you in person. I hope you come here. Because the fractional mechanics is mathematically intensive. If you miss too many sessions, I tell you honestly, you will never ever to catch up. Make sense? If you feel and so it is too mathematically intensive, you can just drop this course. I'm very frankly to tell you that. Because we have a lot of equations. If you keep missing class sessions one by one, then I don't think you can learn things well. This is the characteristic, the nature of this course. Very close to the math course. You know, math is a fundamental of all science and engineering. Do you guys agree? Without science, without math, we just as we are surfing on the surface of the water, and even though we see the treasure box and the water, but we cannot dive to get the treasure box without math. So we need to learn math very, very well. You understand, guys? It's not fun. Math is very boring. I should not say this one in front of math professors. Okay, math is very useful, but math is kind of boring. Equations. Okay, if you have interest, that's very good. However, if you don't have interest, that is a big problem. Very, very important, but it's kind of boring. I like history. History just like a story, right? The math is very, very important. Understand, guys? So I want you to come here as many class sessions as possible, for your benefit. However, if you don't follow this, this is a suggestion, I'm still okay, as long as you can catch up. If you must miss class, please contact your instructor or teaching assistant. We don't have teaching assistant by emailing to inform them of your absence. This is for the courtesy, okay? If you have some something to do, important thing to do, and you just tell me cannot make it for today's class session, I will say okay. Notification should be provided at least 1 hour before class, if possible. All lectures will be recorded as I'm doing now, will be recorded and posted online for future independent study purposes. And if you are unable to attend the lecture in person, you still have access to recorded videos of the lectures online. This is what I have been doing since this is the beginning of the COVID-19. And students need to complete all exams, quizzes, and homework assignments and final project and to get the final grades. So this is the second point, second note. Questions regarding these two notes? In a nutshell, I want you to come here to meet me and to listen and how I instruct, how I the lecture, not how I lecture, what I lecture. And then if you have questions, you ask me. Okay? We have 2 A's, attentive and aggressive. This is what I always tell my students. If we want to get a very, very high GPA with a minimum level of commitment, minimum level of the time, and you need to communicate with your professors as often as you can. Attentive and aggressive in the classroom. Later homework will not be graded without the prior instructor permission. if you have something important to do and during this period, for example, I ask you to turn in your quiz one by some time, by some day. However, you have something important to do and you cannot focus on that one, and you can just email me, tell me these truths, then I will say okay. Okay. No makeup exams, quizzes, homework will be given unless permission and by me is given prior to the scheduled exam, quiz, homework for qualifying absence as determined by the instructor or by university policy. And students will be able to make up a maximum of 2 missed assignments through completion of alternative exams, quizzes, homework within 48 hours of the originally scheduled exams, quiz, homework days. So look at this one very carefully. So if you the professor becomes ill and we have alternative instructor and will teach the course, the cheating will result in an automatic grade of F and for the course. Questions regarding this slide? No questions? No questions? We move on to the next one. So cooperative learning is encouraged. You can talk with each other when you do the homework, but you cannot copy and paste. Copying and pasting itself is cheating. Okay? And you can just talk and then you think the talking is very good for learning. But you must understand the materials, train your own work, and copying homework or computer code. And computer code here means the abacus model. Okay? From another student, cognitive cheating, and both asking homework solutions from and giving homework solutions to other students without permission, my permission, can constitute cheating. You understand, guys? Just like student A and student B. Student A asks the solution from student B, student A is cheating. However, if the student B gives his or her solution to student A back without my permission, that means student B is also cheating. You understand? Okay, I want you guys to clear, okay? So you will not most likely not perform very well in this course unless you do and understand the homework. Homework is very, very important. And for the exams, any discussion, collaboration, or other forms of communication during the exams is prohibited. I will ask you guys to sign the honor sheet and to tell me that you understand this policy very, very well. If you violate this policy, and it is cheating, and also your exam will not be graded. And homework must be legible. Okay, so this is a mechanics course. You must write your homework very, very legibly, and also show units for all quantities. We are engineers, and units play a very, very important role. Do you guys agree? For example, 1 meter, 1 centimeter, totally different. Or $1. If you do not have unit, it does not make any sense. As long as this quantity itself has is a ratio, it's just a ratio, it's just a dimensions. So last one is the newest one, is the newest policy. We just got this one notice from the provost office to talk about this. For this semester, and the provost office give the freedom to all professors and to adapt this policy. But for me, for this course, using generative AI is violating is cheating, okay, in this course, at least for this semester. That means you cannot use generative AI. I don't know what this generative AI means, but generative AI means that you just get something from online and using some very, very fancy, this is a means. Okay? So keep in mind, so this one is using any kind of generative AI is not allowed. what I want my student to do is know the equations, know the derivations very well, and know how to calculate these quantities, and how to use Abacus model, and to analyze the fracture mechanics. That is my expectation. I don't want my students to show on how technology savvy they are to use this generative AI. Okay, we should use AI as a tool instead of use AI for cheating. You understand, guys? Okay. So there are three. This is the policies: academic integrity, disability accommodation, along with the title.